Okay, morning everyone. Welcome to this session number 404. And I will continue with this problem. I study the solution. I'm trying to understand the implementation. In essential is no, it's not of the tutorial. Is this using sliding windows? I think that it's a good approach. I will try to explain here. Even I think that I don't need this calculus here and here. Okay, got it. Well, in essential with this approach using sliding windows is that try to tracking all the time the mean and the max values in the windows, yeah. But not only the max value is tracking the values in increase order and decrease order. But okay, in this case, for example, we have L and R in this, and we have here this with max, no, mean, and this is max. Okay, got it. Now the idea is that tracking the indices here with the mean and the max, yeah, and at the beginning are empty. And in this case, for example, where it's empty, we don't need to add or do anything, because in essential we don't have any element to compare. But it's important that every time essential is that the first is a 4, is a loop. Next to is that a while. What is happening? Sorry. The first is a loop. Next to is the next two is a while. Oh, come on. Sorry, I am testing my pencil. Though there is a while, this is in essential is very similar like monotonic stack. Yeah, it's very similar. The behavior is that try to keep the mean Q and another for have the max Q. Oh, come on. Okay. Okay. In this case, we have the mean in the map. The max, sorry, for keep this, and next to is another while for no, today is not working this table. I need to move to the code because I don't know why it's happening. But well, in essential is that try to keep the mean in the max, and is always have this this Q with these values, yeah. And another while for when you know that the minimum and the current maximum, the current minimum and the current maximum, and if this result is greater that 2, that is exactly this conditional or this constraint, you need to move, in this case, the L pointer, yeah, and remove these elements from the Q. Yeah, in this case, the first that is have the Q. Yeah, in this case the elements is are integer because I need to save the position. In this case is mean, it's equal new linked list. Yeah, and other is max. It's the same. Now here I need the result, but the result should be long. It's equal 0, and integer L it's equal 0, integer right it's equal 0 too. Okay, now having this, the next stat is have a for that transversal all the array nums. In this case, meanwhile, r it's minor that nums length r plus plus, and here is keep the mean and keep the max. Okay, the way to do it this is in essential a while. Again, it's very similar like a monotonic stack, because here we need to say nums in the position mean, in this case because we want to track the mean values, mean dot in this case I'm not sure if it's first or last. Because if I add the mean, the element, the first element of the queue, yeah, for example here, this is the front, yeah, and this is the back. In this case, if here appear the index 2, 4, 8, this because here is for remove, mean that remove I'm not sure if it's first or last. I think that is first. Pull first. Is pull first. Pull first the queue. If this is if this is greater equal that nums in the position r, here first, for example, if we have the imagine that the first is only add, and right now the mean and max, and this is the front and this is the end. Okay, both contain 0, 0, yeah. And in this moment, for example, nums in the position mean pull first is this, the front, that is 5. 5 is greater equal that 4, yeah, means that I need remove this because the other is less is minor, yeah, is remove it, and now it's complete. In this case here I need to validate while mean is empty, and this. Okay, now in this moment it's appeared. The other is similar, like in the positive way. The condition in this case is max dot is empty, and nums in the position max dot pick first. This is a function. If this is minor equal that nums in the position r is max dot remove. Okay, now with this we can have the or keep this monotonic queue or monotonic stack, whatever. And next to is that where after know or after be sure that in this moment both lists contains the minimum and maximum element in the order that appear. Here I need a while, yeah, and in this while I should be validate that if means min dot is empty but negative and max is empty negative, and nums less nums should be max greater than 2. Now in this case is, I think that is max dot pull last because it's the greater element. Pull last, for example here 5 the maximum. Now here appear the 2. In this case, sorry, here I forget, I need to add at last. In this case is r the pointer, and it's the same with this. Means that on the final of this list should be appear the number 4. Okay, no, the number 1 because it's are the indices. Now here is while nums in the position pull last. Let me check. 5 4 now it's 2. Here I am moving the minimum. Max dot pull last. Let me check if I have these elements here. Yeah, at the beginning both have 0 0 and continue with the next. Now we are here. The 4, no sorry, nums in the position pull first, that is 0. 5 it's greater than 4, yeah, I remove, and now it's empty. Now nums in the position 0, 5 is minor equal that 4, no. Okay, in the last the position 1 and 1. Okay, now the next that is while min is not empty and max is not empty, and nums in the position map pull last. In this case the pull last is this, is the greater element, less this. 4 less 4. No. Should we have the first? The mean is 4. In the max, should we have the 0? Yeah, because if I take the last in both is 1 and 1. In this case, nums in the position, well, 4 less 4 is greater than 2. In this case, it's not. Okay, continue with the next. Now the next, we are here. In this case, mean is empty, no, because contain the 1. Nums in the position, okay, 4, because it's index 1. 4 is greater equal 2. Yeah, okay, I need to remove this, and that's it. Now the next that is 5 is minor equal that 2. No, okay, add in the last the position 0, 1, 2, and 2. Okay. I think that in both is last. Now I add in both, and now it's max dot mean is empty. No, max is empty. No, okay. Nums in the position max pull last, that is this 2 less no, in this case should we have the first? I think that here is first. Okay, here is the last in. This is the same. In here is pick first. It's only pick because the other way I am removing the elements. Yeah. Okay, now at last. Now here what happened is let me replicate again the behavior we have here. 0, 1, 2, 3. Okay, this is the indices values. Okay. Okay, we have min and max. At the beginning is only 0 and 0. Don't do anything because it's empty, empty, and empty. Okay. Now the next that is move to the next. The next is the 4. Okay. Min is empty. It's not empty. Okay. And nums in the position pick last. In this case, the pick last is only this element. 5 is greater than 4. Yeah. Okay. Means that I need to remove it. Okay. And now it's the same. Nums in the position. Well, 5 is minor that no, is greater than 4. No, sorry. Here is 5 is greater than 4. Is replace it. Where 5 is minor that in this case is 5 is minor than 4. No. Another way is that other way to see this is the new element is grader that is with the edge, right? Grader as without edge. Graded that last element. And in this case, the new element is minor than the last. In this case is the new element that is 4 is greater than 5, no? Okay, and we need to add in the last the index 1. Okay, and now is ask both lists contain element, yeah, nums in the position max, that is the 0, that is 5 less 4, 5 less 4, it's equal 1. It's not related to this, it's only here is R less L plus 1, and this is for the result. Okay. Now moving with the next is this in the index 2 and the value is 2. Okay, the new element that is the 2. Now the element in min that is this 4 is greater equal that 2. Yeah, okay, I need to remove it. And now the next that is 5 is minor equal 2. No. Okay, now here is add in the last the position of the index 2. Okay, here is 2 and here is 2. Do you see? In essential is that try to keep always the minimum element. In this case the first time is 5, next to is 4, next to is the 2, and it's only have this monotonic stack, or in this case monotonic queue. Add in the last, and now is nums in the position 5 less 2 is greater than 2. Yeah, because 5 less 2 it's equal 3. Yeah. Okay, in this case the first is increase the position L, and next that is please remove all the elements that appear all the elements that minor yeah, here is min dot pick first. I think that is pick first. If it's minor, that L mean that remove first, and it's the same with the other. Yeah, in essential is that okay, in this moment, for example, we have this substring. Yeah, this is our current windows. Now we know that the maximum is 5 and the minimum is 2. We don't know the position, but we know that this is the maximum and minimum. And we are asking, okay, the L is in this position. Means that, why in this position? Because we know that with three we have windows that don't have the a success conditional. We know that we need to remove one element or maybe 2 or 3, but whatever. In this case, is removing only 1. For this reason, this is increasing 1, and we are saying all the indices that are minor that 1, in this case is 0, 1, all the indices minor than 1 should be removed. In this case, the first is remove this, and this keeping the same. Yeah, do you see? Now the minimum is 1. What is 1? Is 4, and we need ask 4 less 2 is greater 2. No, because it's 2, it's not greater, it's equal. Okay, in this moment is stop it, and I can continue, and that's it, I think. What is happening? The Q Java. It's only okay. I wrote wrong. Max pick. It's a function. What else? I think that is only that. Okay. What is happening here? Min remove, max remove. Okay, why? Remove first. Pick first. This is mean. Pick first. Min, max, min. Oh, here is remove. I'm not sure if this remove the last or the first. I think that is for this. I think that here remove last. It's for this. Yeah, I think that it's all. Let me check a few tests. Okay, here. Well, I like this solution because in essential is that applying the sliding windows. I think that is much better that this. No, it's not this. Is Oh well, in this case I think that the pretty queue is a good idea, but the problem with this is that the time for the pretty queue, all the time we need to sort the elements, and in this case it's not, because with the monotonic queue we are tracking the minimum elements until this point. Yeah, I think that is much better because the pretty queue, oh come on, pretty queue time complexity, uh, time complexity is operations. I think that is logarithm n, but let me check. What is the pretty queue? The pretty queue. Insert. No. Okay. Queue. The queue picked up. No. What is the time complex operation? What is the time complex queue operation? What is the operation? I remember to see the time complexity for keep the sorted elements, and is logarithm n. Time complexity. For in Q and the Q methods, time complexity is logarithm n. The problem is with that is that we all the time we are trying to calculate this, and with this it's not, because it's only remove and remove and remove. I think that this is faster, more faster compared with this. Okay. Okay, nice. I will not submit because it's not my solution, but I think that it's a good problem to try after. Okay, now problems. How many times I have? 44. Oh, the daily challenge. Only let me check. Final array state after k multiplication. Okay, no, it's easy. Okay, I think that it's enough for this transmission, but thanks for following this transmission, and I hope see you in the next. Bye bye.